Today I am going to talk about how we use stoichiometric principle in chemical processes, especially in making medicine like aspirin. First, we must know what is stoichiometry. Stoichiometry is the quantitative foundation of chemical reaction, governing the relationship between reactant and product. That means the mathematical method of understanding chemical reaction. It tells how much reactant is needed and how much product we can get in fixed ratio. Now example, pharmaceutical synthesis, aspirin. Then here is the reaction. So C7H6O3 plus C4H6O3, that will produce C9H8O4 plus C12H4O2. So C7H6O3 means salicylic acid, C4H6O3 means acetic anhydride, and that will produce, means salicylic acid and acetic anhydride both are reactant, and that will produce aspirin, that is C9H8O4 aspirin, and C2H4O2, that is acetic acid. Now we have to calculate stoichiometric ratio. Here stoichiometric ratio is 1 is to 1 is to 1 is to 1. What does it mean? Means 1 mole of salicylic acid react with 1 mole of acetic anhydride, that will produce aspirin, 1 mole of aspirin and 1 mole of acetic acid. Means stoichiometric coefficient for salicylic acid 1 and acetic anhydride 1, aspirin 1 and acetic acid also 1. So that's why stoichiometric ratio is 1 is to 1 is to 1 is to 1. Now let's do simple calculation. So here is the problem statement. In that problem statement, here is the problem. 10 gram salicylic acid react with 15 gram acetic anhydride. So first step, calculate moles of reactants. So here moles of salicylic acid amount is 10 gram, that is given, divided by molecular weight, so 138 gram per mole, so that is 0.0725 mole. Means salicylic acid in the reactor, means as a reactant, amount is 0.0725, and moles of acetic anhydride, so amount is given, so that is 15.0 gram divided by molecular weight 102 gram per mole, so that is 0.147 mole. Now from here we have to find out what will be the limiting reagent. So here, since the reaction ratio is 1 is to 1, means if you go in the top, means earlier we already know that stoichiometric ratio is 1 is to 1, means 1 mole salicylic acid react with 1 mole of acetic anhydride. Means since reaction ratio is 1 is to 1, so if you compare the moles directly, so in these two, so that an acetic anhydride is amount is more than salicylic acid. So here limiting reagent or limiting reactant is salicylic acid, because 0.0725 mole less than 0.147 mole. So we got the limiting reagent. Now we have to calculate theoretical yield, means how much aspirin is produced. So that will produce based on the limiting reactant. So here limiting reactant is salicylic acid, means amount is 0.0725 mole, means salicylic acid will be completely converted to the aspirin. So now aspirin uh, as a product, that will produce same amount, that is 0.0725, means aspirin amount will be 0.0725 mole. So now theoretical yield will be 0.0725 mole into molecular weight of aspirin, so that is 180 gram per mole, so that is 13.05 gram aspirin. So now why that aspirin production is very important in drug manufacturing. So this calculation, whatever I calculation I showed you here, so that is very important. This calculation help to reduce waste, lower cost, and make sure we get the best yield from the raw material. So that is the important of this calculation. That's it. Thank you.